After substituting this value in equation 3, we have 2a plus PCR by EI x square bx plus c. On the right hand side, we try to write down in terms of 0x square plus 0x so that we can easily equate the coefficient on the left hand side to the right hand side. So just to give you an idea, so 2a plus we have PCR EI dot x square, again PCR EI dot bx plus PCR EI dot c. On the right hand side we got mf by EI, so 0x squared plus 0x. Now the main idea here is to equate the coefficient here on the left hand side to the right hand side in order to find out the values of a and b. So if I equate to PCR EI x square is equal to 0x square, so I can simply say a is equal to 0. Similarly, if equate this term with this term, we get b is equal to 0. Now the reason being PCR by EI cannot be 0, because if this is going to happen, there will be no buckling, so we don't get this equation. So the coefficient here a and b is equal to 0. So on the right hand side we have mf by EI, we left with this two term, so PCR by EIC is equal to mf by EI, so C becomes mf by PCR. Now this value will substitute mf by PCR in the particular solution here. So the particular solution yp, so a is 0, b is 0, we see mf by PCR. Now the general solution is equal to sum of complementary solution plus particular solution, so it becomes b is equal to, we have c1 cos rx plus c2 sin rx plus mf by PCR. So this is equation 7 or 6. Now in order to find out the coefficient of c1 c2, we'll apply the boundary conditions. So the boundary conditions will be, this is a fixed condition as I said. So the total length here is L, so at the distance, this is A, this is B, at a distance X from top end. So if it is a fixed condition, the boundary conditions are at x is equal to 0, magnitude of deflection is 0. So at x is equal to 0, it means at this point there is no deflection or no buckling happening, so this magnitude of buckling is 0. So we have, if we substitute values in equation 6, we have on the left hand side b is equal to 0, so c1 cos rx, so c, this is 1 plus 0 plus mf by PCR, that gives you c1 is equal to minus mf by PCR. We have another boundary condition, so the slopes dp by dx is equal to 0 at x is equal to 0. So at the fixed end, the slope also 0. So we calculate the dp by dx, so derivative of equation 6. So this is dp by dx minus C1 R sin Rx plus C2 R cos Rx, mf by PCR is 0. Now dB by dx is 0. We'll substitute. So minus C1 dot R multiplied to 0 plus C2 R1. So we get C1, this is 0. So we have C2 dot R is equal to 0. Now C2 dot R is equal to 0. It means either C2 equal to 0 or R is equal to 0. We have R is equal to PCR by EI dot I. So this cannot be 0. So R cannot be 0 because if R is equal to 0, there will be no deflection or buckling. So if we don't have any deflection or buckling, so there is no point to calculate the general solution. So we say that C2 is equal to 0. So C2 is equal to 0. Now substituting these value of C1 and C2 in equation 6, substitute value of C1 and C2 in equation 6, we have V is equal to minus mf by PCR cos Rx plus mf by PCR. So mf we take common, so 1 minus cos Rx. We got another boundary condition, which is at x is equal to L, magnitude of B is equal to 0. So x is equal to L, it means at this point B is equal to 0. So on the left hand side, so this is equation 7. So substitute in equation 7, the left hand side is 0. We have mf by PCR 1 minus cos Rx is equal to 0. This gives us 1 is equal to cos RL. This can be written as RL is equal to n of 2 pi. So cos 2 pi is equal to 1. We got R is equal to PCR by EI square root of n dot 2 pi dot L, which is PCR is equal to n square 4 pi square EI divided by L square. So this is the expression for critical load when the column has fixed conditions.